Welcome. Today we'll solve a radical equation and learn the key steps for working with equations containing square roots. Let's solve the equation. Square root of 3x plus 1 minus square root of x minus 1 equals 2. Before we begin solving, let's note two important things. First, since we're dealing with square roots, we need to ensure that whatever goes inside them is non-negative. This means 3x plus 1 must be greater than or equal to 0, and x minus 1 must be greater than or equal to 0. Second, our strategy will be to isolate one of the radicals and then square both sides to eliminate it. Let's solve this step by step. Step 1. Let's isolate the square root of 3x plus 1 by adding the square root of x minus 1 to both sides. Step 2. Now we can square both sides to eliminate the first radical. Remember, when we square a sum, we need to use the square of each term plus 2 times their product. Step 3. Let's simplify the right side. We get 3x plus 1 equals x plus 3 plus 4 times the square root of x minus 1. Step 4. Subtract x plus 3 from both sides to isolate the radical term. Step 5. Divide both sides by 4 to isolate the radical. Step 6. Square both sides again to eliminate the remaining radical. Step 7. Multiply both sides by 4 to eliminate the fraction. Step 8. Expand the squared term and subtract 4x minus 4 from both sides. Step 9. This is a quadratic equation. We can solve it using the quadratic formula or factoring. Let's factor it. Now, we must check our solutions in the original equation. Remember, we also need to verify that they satisfy our domain conditions. When x equals 1, we get x minus 1 equals 0, which means the square root of x minus 1 is undefined. So x equals 1 is not a solution. When x equals 5, both radicals are defined and the equation is satisfied. Therefore, x equals 5 is our only solution. In conclusion, when solving radical equations, remember to 1. Check domain conditions. 2. Isolate radicals one at a time. 3. Square both sides to eliminate radicals. And 4. Always verify your solutions in the original equation.